right, so within this word rational, do you see this smaller word ratio? Great. And so a rational function, a rational number is a number that can be made into a fraction, or a number that can be expressed as a fraction. So number can be expressed as a fraction. So even if it's a whole number, like if I say, hey, the number 2, can you make that into a fraction? 2 over 1. So whole numbers, integers, those are all rational numbers. Something that wouldn't be a rational number would be pi. Something that square root of 2 can't be written as a fraction. So those would be examples of irrational numbers. All right, so based on this information, I'm just going to tell you that rational functions involve fractions. And we talked about this a little bit yesterday. The independent variable of a rational function will be found in the denominator. Okay, so we've talked about these things. We're just going to formalize these in our notes. We're going to look at 2 parent functions today. The first parent function is 1 over x. All right, so what I'm going to do is I'm going to generate a table here using this parent function. So if I take my fraction 1 over negative 3, I get negative 1/3. 1 over negative 2 is 1/2. 1 over negative 1, negative 1. That's pretty straightforward. When I asked my last class to take 1 and divide it by negative 1/2, they were a little unsure. Okay, so let's just review that. If I take 1 and I divide this by negative 1/2, do you guys remember how we divide by a fraction? You multiply by the reciprocal. So this is equal to 1 times negative 2 over 1, which equals negative 2. So this is how I'll fill in that y value for x is negative 1/2. What do you think the next one's going to be then? If I took 1 and I divided it by negative 1/4, I'd get negative 4. Good. What's 1 divided by 0? Undefined. Good. I know the trap is 0. It's not 0. It's undefined. I can't divide by 0. And then I'm just going to repeat these values without the negatives. So 1/4 will be positive 4, 1/2 will be positive 2, 1, 1/2, and 1/3. So these aren't going to be super easy, super pretty numbers to plot. The only exact values that I can nicely plot are 1, 1, and negative 1, negative 1. Those are my only super nice ones. There we go. I can do a few estimates here to give me a better idea. So if I plot 1/2, I'm going to go up 2. 1/4, I'm going to go up 4. 1, 2, 3, 4. I'll be kind of close to that x-axis. If I did 2, 1, 2, it's going to be a half right there. And then I'm going to get kind of this mirror image down in the 3rd quadrant. So something kind of like this and kind of like this. And I'm going to end up with these curves that approach the axes but do not cross or touch them. This is not very pretty. I think I need to orient my board. So I'm going to have these 2 curves, okay, that approach each axis but don't cross or touch. We do have asymptotes here. We have 2 asymptotes. We have one horizontal asymptote and one vertical asymptote. For the parent function, the asymptotes are the axes. All right, so I'm going to go ahead and write that in my information over here. I'm going to be more specific. I'm going to say my horizontal asymptote and my vertical asymptote. So my horizontal asymptote is y equals 0, and my vertical asymptote is x equals 0. Okay, so if I labeled it here, this would be x equals 0. This would be y equals 0. Now talk to me about the domain. Can I put any number I want in there? All real numbers except 0. Okay, so let's take a look at how I would write that. All real numbers except 0. So I'm going from negative infinity to 0, and 0 is not included. And I'm also going from 0 to positive infinity, where 0 is not included. So the vertical asymptote is where I'm breaking my domain. And then my horizontal asymptote will be where I break the range. So same, this is going to look just the same. Once I get into the parameter changes, if I move this graph to the right, for instance, is it going to affect the range or the domain? The domain. So if I move the graph left and right, it affects the domain. So the domain is affected by h, and the range is going to be affected by k. Okay, the h value will drive the domain, the k value will drive the range. So let's do an example of this. So flip over to the back of your paper that you picked up. I'm going to hop down, hop around. Here we go. So we've got parameter changes. We've got our hk form. The h is in the denominator. The a is in the numerator. The k is what we're adding or subtracting from the fraction. So I'm going to look at example number 1 here. So the h value drives my vertical asymptote. The k value drives my horizontal asymptote. If you were going to just describe the parent function, the changes from the parent function, what would you tell me this graph is doing? Right 1 and up 3. Good. Right 1 and up 3. So my parent function had a vertical asymptote at x equals 0. I'm going to take that vertical asymptote and I'm going to move it to the right. You told me to the right 1. My, what is this? I don't want that. There we go. My horizontal asymptote was y equals 0, and I'm going to move that up 3. 1, 2, 3. There we go. So those are my new asymptotes. I moved everything, every point, including the asymptotes, go to the right 1 and up 3. So now, what were the only nice points that I could plot? Right. It was from the intersection of those asymptotes to the right 1 and up 1, to the left 1 and down 1. And other than that, we can sketch. Okay, because those are the only pretty points. The rest are fractions. At least right now. But we'll see times that we can plot a few more points, but for right now, this is what we're seeing from the parent function. So we're going to graph some of these rational functions that are in the form of a over x minus h plus k. Do you think you could do those? They're pretty straightforward. Okay, so if I were going to do the domain, let's work on the domain here. So I've got all real numbers except x can't be 1, because I moved my vertical asymptote is at 1. So negative infinity to 1. See how that's driven by this h value here? And 1 to infinity. And then I can't have any y values of 3. All real numbers except 3. Negative infinity to 3. And 3 to infinity. And that 3 here was driven by my k value. All right, so let's go back now to the other side of your paper. And the second parent function that we're going to look at today is 1 over x squared. So let's see if we can't fill this in. If I take 1 and I divide this by negative 3 quantity squared, what will that give me? 1/9. If I take 1 and I divide this by negative 2 squared, this will give me 1/4. If I take 1 and I divide this by negative 1 squared, that is going to give me a 1. If you want to, let's slow down here for this fraction. I'm going to take 1 and divide this by negative 1/2 squared. What's the very first thing I would do? Square the 1/2. So this would be 1 over 1/4, and now I can multiply by the reciprocal. So this would be 1 times 4 over 1, which equals 4. So what do you think negative 1/4 will be? 16. 1 over 0 squared is? Undefined. Good job. And then I'll just repeat these values. They will also be positive. 1/4 and 1/9. All right. My horizontal and vertical asymptotes are identical to the last parent function. I have a vertical asymptote at x equals 0 and a horizontal asymptote at y equals 0. So I'm going to write vertical asymptote, horizontal asymptote. My vertical asymptote is x equals 0. My horizontal asymptote is y equals 0. It's not enough to just tell me 0. Okay, you have to give me an equation. You have to know the equations of vertical lines and horizontal lines. If you're not sure, you can look up here and remember Hoy-Bucks. Horizontal lines start with y equals, vertical lines start with x equals. All right, so I'm going to plot the points. So I have 2 exact points. What are my 2 exact points? -1, +1, and +1, +1. The rest I'm just kind of sketching. This time, if I'm going to a half, I'm going up 4. 1, 2, 3, 4. So it's around there. And I have a mirror image over here. If I go, let's see, over 2, I'm going to go up a 4th. So somewhere down here, and there's a mirror image there. So this time my curves, instead of being in quadrants 1 and 2, my curves are going to be in instead of being in 1 and 3, they'll be in 1 and 2. That little tail shouldn't be there. It should be nice curves. Preferably going through your points. So this is what the parent function of 1 over x squared looks like. So let's talk about the domain. All real numbers, but I can't have 0. So this is going to look just like the parent function that we did a second ago. What about the range? 0 to infinity, not including 0. So this only has one piece, because I'm not going to have any of those negative y values. I've just squared everything, so all my negatives have now become positives. All right, so when you see this little squared here, we need to make sure that we make an adjustment to our graph. So as far as describing left, right, up, and down, that's still very straightforward. Tell me what's happening to this parent function here. I'm going to go to the right 3. What else am I going to do? I'm going to go up 5, but that's not the order you're going to tell me. Before you can tell me about up, you got to tell me about that a value. What does that a value tell me to do? Right, I'm going to multiply all the y's by -1, which causes a vertical reflection. So I have a vertical reflection, vertical reflection, and then you would tell me, lastly, up 5. Okay, so that's the order. You're going to describe it to me. So my original vertical asymptote was x equals 0. X equals 0 needs to go to the right 3. To the right 3. So here's my new vertical asymptote at x equals 3. My horizontal asymptote was y equals 0. That's going to go up 5. 1, 2, 3, 4, 5. Okay, so originally, when we did the parent function, we had these 2 points marked. What's going to happen to those 2 points? They're going to flip vertically. So they're going to come down here. All right, so my y values became negative, and so now I'm going to sketch my curves. And it's going to look something like that. So what's the domain of my new graph here? Negative infinity, not including 3. And then what about the range? Negative infinity to 5, not including 5. From negative infinity to 5, neither of those included. Good. So the h value is going to drive your domain. The k value is going to drive the range. If I asked you, which I didn't hear, but if I asked you for the vertical asymptote, x equals 3, which is going to be the same number that you have here. If I asked you for the horizontal asymptote, you're going to tell me y equals 5, which is the same value you're going to see in your range. Okay, so how are the functions different from the previous functions you've studied? Well, we have 2 asymptotes instead of 1, right? So we have 2 asymptotes. But the big thing I want you to take away is that we have a discontinuity here. We had to pick up our pencil to draw the entire graph. Every single function we studied before today, we never had to pick up our pencil. So this function has a discontinuity. All right, you can say it's not continuous, but has a discontinuity. There we go. Then if I look at the 2 we did today, how are those 2 different from each other? So if I compare 1 over x, I could say has negative y values versus 1 over x squared only has positive y values. I'm not going to put that dash in there. That looks like a negative. Well, has positive y values. But both of them had 2 asymptotes, right? Both of them that had a vertical and a horizontal asymptote. Because neither of them could have a 0 in the denominator. So if I can never have a 0 in the denominator, y will never be 0. So that's why there's 2 vertical asymptotes, because denominator, can't be equal to 0, and because the denominator can't be equal to 0, the whole function's not going to have a y value equal to 0. We already did these asymptotes, x equals 0, y equals 0. I'm not going to worry about the domain and range. We already have that filled in, right? Okay.